Hello. Morning. Thanks for taking the time to attend. My name is Jay Mezher. I work with Parsons Brinckerhoff, now part of the WSP Parsons Brinckerhoff group. I'm based in New York. I've been with the company for 15 years now, and my role is to direct virtual design and construction and building information modeling. We manage a national group that helps the company implement BIM and then also look for emerging technologies. The panel today is BIM for civil, or if you want to call it CIM, Civil Integrated Management. It's pretty much the same, a lot of names out there. I have Steve Stepanopoulos with me and JP Gaultier from Autodesk and Bentley. I'll start with, let me see here, with a brief overview on BIM for civil, and then talk briefly about the framework on how we build these models, how we use them, because mostly civil jobs involve infrastructure. Highlight some of the BIM technologies, and then we follow it by a panel discussion. So BIM use framework. On a lot of jobs that we work on, we deal with complex existing conditions. A lot of times it requires the use of surveying, laser scanning, GIS, all sorts of survey data and information to capture existing conditions. Civil by itself is a discipline, but it often requires also the integration of facilities. So let's say you're working on a bridge. There are components in a bridge or in a tunnel that are not specifically civil. So you have to look for those different disciplines. And if you're required to deliver a job in BIM, then you must be able to extract all these different models to aggregate them. So you have facilities, structures, mechanical, electrical, roadway, and then of course the urban development around it. What we focus on a lot is just how do we integrate all these different models into one integrated model that's going to give me my construction drawings, that's going to help me with visualization, quantity takeoff, design coordination, and then during the construction phase, constructability 4D, 5D. And one of the most important things that we're seeing right now in the industry is clients requiring that these models be linked to their asset management and their operation and maintenance systems. So I'll go briefly through some of these technologies and how they've been used on projects. This is reality capture, capturing existing conditions. Laser scanning is becoming a standard in RFPs and in projects. Clients are hiring surveyors or they have their own teams to survey and laser scan existing facilities. So the uses are multiple. First is validation of proposed design with existing conditions on projects like a tunnel. It's really critical to have those spaces clear, measured and surveyed accurately so you can overlay it with a proposed design, make sure there are no conflicts, and submit it to the contractor and eventually to the owner. The other use of laser scanning has been project handoff. On a lot of projects that involve multiple contract packages, when you hand off one package from one contractor to the other, there's certain tolerances that you have to be within in terms of construction, and the only way to identify these tolerances and to make sure that the contractor built the job according to the design is to laser scan it, overlay it with a design model, and then approve the work. Model-based design, it's quickly making its way into infrastructure jobs. It's not as adopted as much as doesn't have a level of adoption as the building side of things, but it's definitely getting there. A lot of components of the infrastructure jobs are already being modeled in 3D. So the highway, corridor modeling, surfaces, it's been designed in 3D even before the buildings, even before the building sector adopted it. But it's aggregating those other model elements, these other disciplines that is still lagging behind, but it's definitely becoming a requirement on several of these jobs that we've been working on, and agencies are starting to mandate it. Structural detailing review and documentation, this is also the next level. We're seeing it on several jobs right now where you already have your model-based design process in place, but it's taking it to the next level when clients and designers are seeing the benefits, that I can get into the detail of modeling rebar and looking at interferences and clashes. In this case, it's a tunnel liner. We wanted to make sure that the rebar is not going to conflict with the dowels that connect the liners, and then also a bridge pier segment to generate all the rebar from the BIM model, because that would save the contractors money, and it's a much more efficient process in line with lean construction. Automated machine guidance is huge in the civil industry. Basically, it's surveying existing conditions and then building the proposed model and then linking it using Trimble or like our other systems to the grading and excavation machinery, and then having the model through GPS guide you on which parts need to be excavated or graded. FHWA in their tech brief said that there's huge cost savings in there. It could cut survey costs by up to 75%. And the biggest benefit also is safety. You have less people in the field because of these automated processes. Model integration, this is the previous panel touched on it. It's a really important part of all these different processes, because if you have infrastructure jobs that where different groups are working on different disciplines, unless you integrate all these disciplines into one model, you're not going to be able to leverage the information. This is from the Alaskan Way Viaduct project in Seattle, the SR-99 bored tunnel. As you can see here, you have everything aggregated into one model, above surface and below surface. So there's the existing conditions, all the piers, and then there's the proposed tunnel. This was used throughout the project life cycle. BIM for prefabrication, again, we're talking about prefabrication with cast-in-place concrete. Those are immersed tunnel tubes that we worked on and modeled everything in 3D, and the setup of the formwork so that they can cast the concrete was generated from the BIM model. Model-driven visualization, you've probably seen a lot of those visualizations, but this is one of the best byproducts of model-based approach, because on a lot of these jobs, you're dealing with audiences and stakeholders that not necessarily know how to read complex information, especially when it comes to civil drawings, architecture drawings, construction schedules. So again, this is from the Seattle job, where you can see we modeled everything above ground. And towards the end of the job, we had the entire city modeled above ground, below ground, and the proposed designs. 4D modeling, again, linking the model dynamically to a P6 schedule or any scheduling information would give you a 4D model that you could see construction sequencing. You can link multiple schedules to see side-by-side comparisons, and then, again, you could use it for the public and stakeholder communication. Next step is 5D modeling. So this is an example of some of the dashboards and the 5D modeling research that we've been doing. So now I have my 3D geometry and project information in one portal. I have my activities. I have my planned and actual schedules, so I can baseline it and look at the associated risks based on the schedule differences. And then I have my cost value by activity. So if I cost load my schedule, I'll be able to look at a 5D model and then see the progress and cash flow across time. This is one of the concepts that's being used by the New York State DOT for the K Bridge. NYS DOT put out an RFP, and they required the contractor in the design-build contract to submit a 5D model, because progress payments are based on their cost-loaded schedule. So not only you can see it in the schedule, but also you could see a snapshot of where the work is. This is an example of a 5D model where you could see the project build across time, and then you could see the dashboards also on the right Any information that's housed in the database is probably going to be displayed on the right, so I can look at my cost split by equipment, labor, material. I can look at my cost-loaded schedule, and then I can see by project phase what are the risks associated with the project. And then finally, the linking BIM to asset management. We think that's the next big thing. And like I said, several of the clients, agencies on bridges, tunnels, and other infrastructure jobs are requiring model-based design, but more importantly, one of the deliverables is to link the assets and the operation and maintenance side to the models themselves. Now that said, it's a game changer because when you're designing and you're building your job, you're gonna have to take all these into account. And I'm a few seconds late. And then finally, digital cities. With multiple projects being built in 3D, you end up with an entire database of a city. This is, again, the city of Seattle. We worked on several jobs over there, and now we have the entire city mapped out in 3D and linked to all the different projects.